All right, here we go with Unit 6, Lesson 1 on exponents. Today we're going to be looking at simplifying expressions with exponents. The first thing we want to remember is what an exponent is. The exponent is this number that's way up here in the corner. This number up here that represents how many times the base number, this one down here, is going to be multiplied by itself. So if we want to represent this as an extended product, remember the word product means to multiply, and to extend just means to stretch out. So all this is saying is I have the number 4, which is my base, and I'm going to multiply it, hence the word product, 3 times. So 4 times 4 times 4. Okay? It is not 4 times 3. It's 4 times itself that many times. That's what the exponent represents. Same thing here. If I have x, x is my base, and my exponent is 4. So that means I have the base, x, times itself exactly 4 times. X times x times x times x. Here, my base is this whole thing, 2x. And my exponent is the 3. So I have the base, again, 2x times 2x times 2x. I have that 3 times. But we know a little bit about multiplication. We know the fact that the properties of multiplication, one of them is that it is commutative, which means we can move pieces around. And remember, between all of these constants and variables is also just multiplication. So why don't I regroup these with all of the constants in front, 2 times 2 times 2, and all of the variables in the back times x times x times x. If I do that, then I can actually go backwards and say, well, this initial expression is going to be equal to, what is 2 times 2 times 2? It's 8, or the base 2, how many times? 1, 2, 3, 2 to the third. And here I have the base x, how many times? To the third. So this expression here and this are equivalent expressions. Let's take a look at this next one here. It says, if y squared times y cubed is simplified, what is the new exponent? Well, let's use the same extended product idea to see exactly what's going on here. Y squared, if I rewrite that, that's just going to be y times y. That is, the base is y, and the exponent is 2, so I have y times itself twice. I also have another base of y, and that's being multiplied times itself 3 times. So if I simplify this now, I could say I have the base y, because it's all y here, and how many times do I have it? 1, 2, 3, 4, 5. So I have y times itself 5 times. So that new exponent is going to be y to the 5th. And we'll see eventually here that one of our rules is whenever I'm multiplying the same bases with exponents, it equals the exponents added together. And that's exactly what we got here, y to the 5th. Let's take a look at some function notation. If f of x equals 4x cubed plus 2, then f of negative 1 equals what? Well, all I'm going to do is I'm going to plug in negative 1 in for x, right? So f of negative 1 equals 4 times negative 1 cubed plus 2. Over on the side here, I'm going to just show you what negative 1 cubed is. So that would be negative 1 times negative 1 times negative 1. Well, negative 1 times negative 1 is positive 1, and positive 1 times negative 1 is negative 1 again. So that just means 4 times negative 1 plus 2. And 4 times negative 1 is negative 4, plus 2 is going to tell me negative 2. So f of negative 1 equals negative 2. All right, now this is a very common question, this last one here. it's going to tell us to take some sort of product of constants and variables with different exponents and write it in simplest form. Well, simplest form always means that I'm going to have one constant. It could be a fraction, but one constant out front, and every single variable that we're going to have will be written with a positive exponent, and every base will have been combined to, any similar bases will have all been combined. Similar to what we did up here in part 2, question 2. So let's see what this means. 3t squared. Well, let me write this out in the extended product form here. So 3 times t again, right? T squared is t times t. I also have this 2t squared all cubed. So in other words, I have 2t squared, that whole thing, 3 times. So let me write that out. I have 2t squared times 2t squared times 2t squared. But this 2t squared could be simplified a little bit. So let me start here, 3 times t times t. This 2t squared could be written as 2 times t times t, and so can every subsequent 2t squared. 2 times t times t, and again 2 times t times t. Alright, this looks like this huge mess. Well, let me again pull all the constants out front. So 3 times 2 times 2 times 2. And we put all the t's in the back. 1, 2, 3, 4, 5, 6, 7, 8. So times t, times t, times t, times t, times t, 1, 2, 3, or 5, times t, times t, times t. So there's all 8 of them. Okay. Now, lastly, let's recombine everything so we can write it in its simplest form. So 3 times 2 is 6, and 6 times 2 is 12, and 12 times 2 is 24. And I have 1, 2, 3, 4, 5, 6, 7, 8 t's, so all have the same base, so t to the 8th power. And that is in simplified form. Notice I have one constant and one base with a positive exponent. Alright, so let's consider the expression 3y to the 5th over 6y cubed. And let's try to take this and make it into a simplified equivalent expression. So one of the first things we want to be able to do is realize that we can simplify this through factoring. Now, factoring just simply means let's see what all of the pieces are and then create ones. So in other words, the top and the bottom of a fraction that are the same, right? Anything over itself equals 1. So let's try to do that. First, let's take this expression and let's write it in the extended product form. So 3 times y times y times y times y times y. And that's over, I'm going to write the number 6 as 3 times 2. 3 times 2 times y times y times y. Now, why did I choose 3 times 2? I chose 3 times 2 because I had a 3 in the top, and if I have a 3 in the bottom, again, I can make those into the number 1. Alright, so now let's try to break this up. Let's take anything that can possibly match and create its own fraction. So in other words, we're going to use the commutative property to move things around so that we can kind of group things together and make the number 1. So let's see. Let me keep I have a 3 in the top and I have a 3 in the bottom. I have a y and another y. I have a y and another y. And I have a y and another y. And it looks like that's all of the stuff that can possibly be paired up together. So 3y, that's the same thing as saying 3y cubed. Right? Let's do that. So it has 3y cubed and 3y cubed. And anything over itself always equals 1. Okay, but we have some stuff that's left over. We have these two y's here, and we have this number 2 here. So in the top, we still have y squared, right? Y times y is y squared. And in the bottom, we have a 2. So we have now wrote this expression in a way that is going to end up simplifying very nicely for us. We've combined all of the parts that are going to simplify to the number 1. And the reason we're doing that is because when we multiply 1 times anything else, anything else is not going to change. Okay, so now let's simplify this expression. Oh, perfect. Okay, so this 3y cubed, we write it like this many times. Let me rewrite the whole thing here. Times y squared over 2. What do? We say this cancels each other out, right? It just becomes a 1. And well, that was easy. What was left when we did that? Well, 1 times y squared over 2 is just y squared over 2. And that's my solution. That is what this thing, this expression simplifies down to. Let's try it again, maybe a little bit more complex. We're going to simplify this completely. Okay, so first thing I want to do is just so I can take a good look at what's going on here is I want to write this in that extended product form. Eventually you won't need to do this, but I want to do it right now so that I can see what's going on with all of these parts. So I have this base 2x to the 4th to this exponent 3. So in other words, I have the base 2x to the 4th times itself 3 times, which means I have this 2x to the 4th times 2x to the 4th times 2x to the 4th. And in the bottom, I have this 4x to the 6th. I'm just going to leave that alone for 1 second. And then in the next step, we will write it in its extended product form. Okay, so let's do that then. Let's write everything in its extended product form. So let's start with the top. So I have 2x to the 4th. So that's x times x times x. Times x again. And then I have that again. Times 2 times x times x times x times x. Then I have it again, times 2 times x times x times x times x. Okay, and that is over 4. Or I could write 4 as 2 times 2, since I have a whole lot of 2's in the top. And then I have x times x times x times x times x times x, x to the 6th. All right, let's do the same thing we did in that last problem. Let's kind of group things together in a way that we can create the number 1. So in other words, the same thing over the same thing will always be 1. Maybe by rewriting the top, the numerator, as 2 times 2 times 2. Let's group it all together like that. All of the 2's together, and then all of the x's. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's in the top. And in the bottom, I have 2 times 2 and 6 x's. 1, 2, 3, 4, 5, 6. Okay, well look, if I do this, right, the 2's, the x, 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 right, they would all become 1, wouldn't they? It's the same thing over itself. And what's left here? Well, I'm left with just a 2 and 1, 2, 3, 4, 5, 6 x's. So I'm left with just 2x to the 6th. And that's all that you have to do. Now we will discover some rules that we can apply to make this a little bit simpler, and you don't have to write everything out every time like this. We will see that there's a product rule. So in other words, if you have a power or a base with a power raised to another power, you multiply the powers together. We'll see if you just multiply two similar bases with powers, you add the exponents together. But we want to see what's actually happening first, which is why we're going through it like this and actually listing things out and making sure we have a formal understanding of what exponents are and how to use them. Alright, well that's everything for today. We will be working a lot with this tomorrow in class. I will see you then.